Being a math teacher, just designing video games isn't something that I can tie into what I teach. I need to be teaching math concepts, so I worked with Krista and Andre from AgentSheets, and we came up with a simulation of a virus, and we did a module on the virus attack simulation where the kids took a lot of data, kept count of people that died from a virus, people that survived, and we did all types of averages, mean, median, mode, range. They learned how to make box plots and dot plots, and so it just perfectly tied into our curriculum, and the kids just had a blast making their own virus and making their people die, and it's just been a great thing to get the kids excited about using the computers, using the AgentSheets program, and seeing how it ties into math. But what we're going to do is act out the simulation that you're going to be using on the computers next week. You're going to use it on Monday, and then you're going to make it. But you need to understand how it works. So we've got to go through some rules of the simulation, and then you each need to be assigned as an adult, an old person, which we call an oldster, or a child. So we need... Does anybody know why we're doing this? This is a virus we're talking about. Why are we doing this?
To see the percentages and chances.
We're going to be talking about percentages and chances. Okay? There are a lot of viruses out there. There are a lot of things that are deadly, but we have medicines for them. And a lot of this will apply more on Monday than it does today, but when there's a virus out there and you can only give so many people an inoculation, what's an inoculation?
Medicine to get you better.
Medicine. It's a shot to keep you from getting it, actually. It's not to get you better. It's to keep you from getting it. Like a lot of you have had the flu shot. Before you can even enroll in school, you have to have shots. So roll again. Nobody's beside Kaylee.
Oh, wait. 3.
No. Were you supposed to bump into him? Okay, let's leave you there. Okay, so now, Kaylee is beside Jose. We may have to do this a little more on Monday. That's okay though. Kaylee is beside Jose, so now you have to do, you're next to a sick person. Are you going to get sick or not?
Yes.
We don't know. He's going to roll the sick roll. Okay, so do your roll and tell us what you get.
5.
He's a 5. He's an adult. He is an adult. Adult rolls a 5 on the sick roll. What happens?
Stay healthy.
He stays healthy. Okay, so Kaylee is sick. She needs to do a recovery roll to see if she gets better. What'd you roll? A 6. So she is a, what are you? Where's your sticker?
Adult.
She's an adult. And she rolled a 6. So she's going to become healthy. Right?
So then who's sick now?
Okay, so you are not sick now. Now, do we have any sick people?
No.
No. She got better before she passed her virus on to anybody. The simulation is over because there are no sick people.
A little bit about why are we doing this? When would I ever really need to use statistics? Okay. And what do people use this for anyway? So they do. Sports is a good example of when they use stats. So what we're going to look at though is modeling something. And so there are lots of examples where you can do something on a computer that you can't do in real life.
So you're going to start, we have 0 inoculations. Nobody's going to get them at all. And we're going to watch our properties up here. And look how many are dying.
The kids are
They're dying like crazy. Yes, and like Drake said, if you notice the kids are dying faster, there's a lot more adults dead though.
Oh jeez. Oh snap. Look at all that. There's more adults.
There are more adults, yes.
There's 2 sick.
Holy. They're dropping like that, man.
Dead 107. Who's the ugly green ones? That's a old lady.
Look how many sick we have left. We only have 1 sick person left.
Where?
We don't see it, they're down below. Remember, I had to scroll. There's only 1 sick person left. They're either going to die or get better. We can watch this and see if they die or not.
Yeah, kill others. Die already! Get back here, people.
So she died.
She ate him.
Angel, how many died? 90 died. And last time 108 died. Why didn't we get the same results?
Different percentage. Every time is different.
I didn't change any percentages, did I?
Every time is different.
Joey.
Every time is different, and
why is every time different?
They died quicker.
But why is every time different?
Well, it's hard to explain. There's a percent of people that, their immune system is like stronger.
Right, there are variables in this, right? There's a percent involved. So just because I give them the same percent, doesn't mean the same thing happens every time. You know, if you flip a coin, 50% heads, 50% tails. So if you flipped it 10 times and wrote down how many were heads, and you flipped it 10 times again, would you get the exact same number again? No, a percent chance is just that, it's a chance. So you're going to run these 5 times, because after a while, you're going to get zeroed in on what the real percentages are. Okay, so you're going to run that 5 times again. Recording how many died, oldsters, kids, adults in total.
Right. Any questions about what you need to do or how you need to get started? Right. The first thing, before I send you back, the first thing you need to do is just leave it as is and run it 5 times and write down the data.
What do you think for
5 times, okay? Each one of you is going to do this and collect your data, and then when we bring it all back together, we'll have a lot of data to use so we can look at some averages overall and some spread and variation.
Okay, so what are you trying to do? Find out what 10% of 50? What's 10% of 50? 5, yeah. So write that down. Alright. Yeah. Perfect. And so now, when you go to your properties right here, make sure you reset first. Okay, good, it's all reset. Now you're going to type in that information and then run it 5 times.
Other things.
Did you like programming it?
Yeah, programming AgentSheets was very fun.
The hardest part was the agent simulation. That we had to keep doing it 5 times because 50%, 30% of people had the virus, and we had to keep like resetting it to how many people died, and it was very fun.
So what did you learn about when a bigger percentage of people had a virus? What happened with the spread through the population?
That if more people had it, it
would spread faster.
It would have spread faster.
But did you get the same kind of mortality rate in the end, or?
No.
No, different mortality rates too?
Yeah.
So you learned how to calculate all of that?
For the 0%, it was like almost all in the 90s, like 90, 80s. And then for the 50 was the lowest, like from 20, and probably 40 was the highest.
Yeah.
So everybody's data kind of merged with the different...
And then we made a graph about that, a plot.
Some people got the same, some people got different.
And then we made quartiles about that. It was very fun.
Great. Okay, thanks a lot, guys.